In this lesson, we will be adding and subtracting monomials and polynomials. And so we'll start off with some monomials. And basically what a monomial is it's a one-digit number, or it could be a variable, or it could even be a number with a variable. That is a coefficient in a variable. But the variable can only be to a whole number exponent. So I can't have a negative exponent. We can't divide by an unknown. So that's what a monomial is. These are a bunch of different monomials. There's 3 of them altogether. And what we're going to do is just collect like terms. That's all. So you look for the terms that have the same variable raised to the same power. So like this one here, 7a squared. We can combine that with a 10a squared. We cannot combine it with the 9a because this one does not have the same exponent as the other 2. So we go ahead and collect some like terms. Since they are both positive, we will add them together. 17a squared. And then we just bring down that plus 9a. So that's all you're going to do on those. So we have some other problems here to practice. Sometimes we didn't have a sign here. Let's put a minus sign right here. And here we have some variables that have the same exponent, like this one here, this 700x squared. And this negative 1900ths x squared. So we can combine those two. So since they're they're not next to each other, it doesn't mean we can't combine them. We can use that property that allows us to move terms. It's called the commutative property. Important thing to remember with decimals is make sure you line up those decimals as you do addition or subtraction. So notice how I line up those decimals, and then I go ahead and do that subtraction because they're opposite in sign, and I end up with a 1200ths. So 1200ths x squared is what I get. Now it's negative because there's more negatives than positives. Now I can't combine it with that 3200ths x because that term doesn't have an x squared, just an x. So there is our answer. Well, another problem to try. Here we have a couple different exponents, 3 different types. X to the third, x squared, and just an x to the first power if you don't see the exponent. Well, we can only combine the ones with the same variables raised to the same power. So these terms right here. Now, when we do this, see how they're kind of out of order here. We got the x to the thirds first, and we are going to put that number first because it has the highest exponent. Typically, we put numbers in descending order according to the exponent on the variable that's closest to a. And so the lower number in the alphabet, or the lower letter in the alphabet, I guess. Anyhow, this term will go first because it has the highest exponent. So they're both the same sign, so it's going to force me to add those 2 numbers together. And when I do that, I end up with a negative 11x to the third power. Now we take a look at the x squared. We'll write that number next because it is the next lower exponent on the variable x. And we'll write the 5x last. So there it is. Well, let's try another one. This one has more than one variable. That's okay, but the property is still the same. You can only combine the ones with the same variables raised to the same power. So x squared y's we can combine with another x squared y's. And xy can be combined with xy. So here we will collect the x squared y's together. Look at the sign in front of the term, never behind. And so when I do that, I'll go ahead and add those 2 numbers since they are the same sign. And I just count them up. There's 5 of them, and 3 of them make 8 of them. So 8x squared y's. Now we look at the xy's. We've got a negative 2xy. We've got a positive 3xy. So those are opposite in sign, so I'm going to end up subtracting those 2 numbers. So that makes a positive xy, or a positive 1xy for that matter. And that's it. That's as far as we go. Well, here is some adding and subtracting of polynomials. Polynomials are basically a bunch of monomials being added together with a parenthesis around them. And what that represents is it represents a number. So we're taking this number, we just don't know what n is, and we're going to add it to this number. That's why the parentheses are around it. It means that we have to do the work in the parentheses first. However, we can rewrite this in a way where we just have one polynomial rather than 2. And the way I like doing it is when I'm adding polynomials is I like to use this column method. So if this were the problem, what I'd do is I would take the second number here, or the first, it doesn't really matter, but since the second one only has two terms, we call that a binomial, I'm going to write those terms that are like underneath this trinomial that has three terms. So see how it's 18n squared? I can combine that with the 5n squared. So I'm going to write the 18n squared underneath this term. See this 9? Well, I can only combine it with the 6, so I'm going to write it underneath that term. And then I'm going to add them together. See, if you use this column method, it makes the addition easier. It's the same reason why when we add or subtract numbers, we typically put them in columns. Well, here we're just adding or subtracting the coefficients of like terms. So we go ahead and do the work. Here we're adding 5n squareds and 18n squared, so we end up with 23n squared. Nothing to combine with that 3n. And over here we just add the 6 and the 9, the constants together, and we end up with positive 15. And that's our answer. Notice how it's in descending order, highest exponent down to the lowest one. Constants always last. Well, let's take a look at another one here. Here we have same sort of thing. So it doesn't matter which way you bring them to. Typically, I just always bring them from this term. When we're adding, it's easiest just to bring this one over here, down underneath the ones that are like over on this side. So we've got an 8t squared. So I'm putting 8t squared underneath the 2t squared. And then the plus 9t. And then I just add the numbers up. So 10t squared here, 2 and 8 make 10. And then I add up the other numbers. Now the other numbers are opposite in sign, so we're going to end up having to subtract those numbers. Now look at the sign here. The more positives than negatives, so it makes a positive 1t, or just a positive t. There is our answer. Well, here's an interesting one. See, this one's different because remember how I said before I was going to move the binomial underneath the trinomial. I do the same sort of thing on this one. You don't have to. You could put this term here way over on this side. Either way, it doesn't really matter. But I find it easier just to take this binomial and put it underneath the terms of the trinomial. So I do that. I'm going to move this negative 3x. It's going to go right here. Positive 12 will go underneath the negative 18. And then I can just add them up. And see, it's all lined up for me to add. And nothing to combine with that 9x squared, so I just end up with a 9x squared. Here they're opposite in sign, so I subtract negative x. Opposite signs subtract, negative 6. And there is the answer. Well, on this next one, though, it's not a addition problem, it's a subtraction. So there's a rule we need to do first. We want to change it to addition. Now, the way we do that is think of this a couple different ways. Remember adding the opposite. If you had, let's say, 3 minus negative 2, we would add the opposite. We would change this subtraction to plus and change this to its opposite sign. You could do the same thing with this. So that's what I'm going to end up doing. I'm going to add the opposite. But I can't just add the opposite of the 2c to the 4th. I need to add the opposite to every number inside this set of parentheses. So subtraction to addition, opposite of every number here. So notice how all those terms change their opposite sign. Another way to think about it is like a negative 1 right here, and you're distributing a negative over those terms. Either way, once you're done doing that, now you can do the work that we had done before. We can just take the terms that are like and move them underneath the terms that we'll combine with. So the negative 2c to the 4th goes here, positive 3c here, and a negative 4 there, underneath the positive 6. And then just add them up. And then from there, when we add them, opposite sign subtract, same sign add. So it makes a 4c to the 4th, positive 11c. Notice they're the same sign, so I add, opposite signs I subtracted. Opposite signs here, so I'll subtract this as well. That makes 2. And there is our answer. Part 2 will have a few more adding and subtracting polynomials, mainly subtracting, since we did 3 adding here, and then also a word problem or two.